For centuries, people believed that the Earth was flat. This belief was not just a random thought, but a deeply ingrained worldview that shaped how ancient civilizations understood their place in the cosmos. They looked up at the sky and saw a vast expanse that seemed to stretch endlessly, and they looked around and saw a horizon that appeared perfectly level. This led them to conclude that the Earth must be flat, like a disk floating in a cosmic ocean. They imagined it as a vast disk, surrounded by a great encircling ocean. This ocean was thought to be the edge of the world, beyond which lay unknown and mysterious realms. The idea of falling off the edge of the Earth was a genuine fear for many, with the sky arching overhead like a dome. This dome was often thought to be a solid, crystalline structure, embedded with stars that moved in a predictable pattern. The sun, moon, and planets were believed to travel across this dome, influencing the seasons and the passage of time. This idea seemed to make sense, based on what they could see around them. The horizon always appeared flat, no matter where they stood. Mountains and valleys existed, but these were seen as mere irregularities on an otherwise flat surface. After all, the ground beneath our feet does appear flat. When you walk across a field or look out over a plain, there's no obvious curvature. This everyday experience reinforced the flat Earth belief. The concept of a flat Earth was prevalent in many ancient cultures. From the Babylonians to the Greeks, and even in early Chinese and Indian cosmologies, the flat Earth model was a common thread. Each culture had its own variations, but the core idea remained the same. It was often intertwined with mythology and religious beliefs. Many creation myths describe the Earth as a flat surface, supported by pillars or floating on water. These stories were passed down through generations, becoming an integral part of cultural identity. However, as scientific knowledge advanced, this idea gradually gave way to the understanding that our planet is, in fact, a sphere. The work of astronomers and explorers, coupled with mathematical and observational evidence, slowly but surely dismantled the flat Earth model. Today, we know that the Earth is a globe spinning in the vastness of space, a testament to the power of human curiosity and the quest for knowledge. One of the most fundamental laws of physics is gravity. Discovered by Sir Isaac Newton in the 17th century, gravity is the force that attracts two bodies towards each other. Newton's law of universal gravitation states that every mass attracts every other mass in the universe, and the force between them is proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. It's the force that pulls everything towards the center of the Earth. This is why when you drop an object it falls to the ground. The apple falling from the tree, famously observed by Newton, is a classic example of gravity in action. Gravity is what gives weight to physical objects and causes the tides. On a spherical Earth, gravity pulls equally from all directions, keeping everything firmly grounded. This uniform pull towards the center of the Earth ensures that no matter where you are on the planet, you feel the same gravitational force pulling you downwards. This is why people can stand upright and walk around comfortably on the surface of our round planet. But what would happen if the Earth were flat? This question has intrigued many and sparked numerous debates. A flat Earth would present a completely different scenario for how gravity operates. The implications of a flat Earth on gravity are profound and would drastically alter our everyday experiences. On a flat Earth, gravity would behave very differently. Instead of pulling objects towards the center of a spherical planet, gravity would pull everything towards the center of the flat disk. This central point would act as the gravitational hub, creating a unique gravitational field. Instead of pulling towards the center of the planet, it would pull towards the center of the disk. This means that objects on the surface of the flat Earth would experience a pull towards this central point, creating a radial gravitational effect. The further you move from the center, the more pronounced this effect would become. This means that the further you traveled from the center, the more you would feel gravity pulling you sideways. At the edges of the flat Earth, this sideways pull would be so strong that it would be difficult to stand upright. Objects and people would feel a constant tug towards the center, making life on a flat Earth quite challenging and fundamentally different from our current experience on a spherical planet. Navigation plays a crucial role in our modern world. Whether we are commuting to work, planning a vacation, or shipping goods across continents, the ability to navigate accurately and efficiently is essential. From ships sailing across oceans to airplanes soaring through the sky, our understanding of navigation has evolved tremendously over the centuries. We rely on our understanding of the Earth's shape to travel efficiently. Pilots use sophisticated instruments to chart their courses, while sailors have long depended on the stars and the horizon to find their way. But how would navigation work on a flat Earth? This question challenges the very foundation of our navigational systems. On a flat Earth, traditional methods of navigation such as using a compass or following the stars would be unreliable. The compass, which has been a trusted tool for centuries, would no longer point to a consistent magnetic north. This is because the Earth's magnetic field, which is responsible for the compass's direction, is generated by its rotation. Without a spherical Earth and its rotating core, the magnetic field would be drastically different, if it existed at all. Moreover, the stars wouldn't appear in the same way in the sky. On our spherical Earth, the stars shift positions as we move from one hemisphere to another, providing a celestial map that has guided explorers for millennia. Ancient navigators used tools like the sextant and astrolabe to measure the angles of stars above the horizon, allowing them to determine their latitude. These methods would be rendered useless on a flat Earth, where the sky's appearance would be inconsistent and unpredictable. Today we rely heavily on GPS technology, which depends on a network of satellites orbiting the Earth. These satellites provide precise location data by triangulating signals based on the Earth's curvature. On a flat Earth, this system would fail, as the geometry required for accurate triangulation would be impossible. As we look to the future, advancements in navigation technology continue to push the boundaries of what is possible. Autonomous vehicles, drones, and even space travel rely on our understanding of a spherical Earth. Imagining a flat Earth forces us to reconsider these advancements and the fundamental principles that make them work. Ultimately, our ability to navigate the world is deeply intertwined with our understanding of its shape. The concept of a flat Earth presents a fascinating thought experiment, but it also highlights the incredible complexity and precision of the systems we depend on every day. Our understanding of astronomy is also deeply intertwined with the spherical shape of the Earth. We observe the stars, planets, and other celestial objects from our vantage point on this rotating sphere. How would our view of the cosmos change if the Earth were flat? On a flat Earth, the stars would appear to move in straight lines across the sky, rather than rotating around a central point. Additionally, phenomena such as eclipses and the phases of the moon would be difficult if not impossible to explain. Section 5. The Earth's shape evidence from home. Even without venturing into space, there's ample evidence from our everyday experiences that the Earth is not flat. Simple observations of our surroundings provide compelling proof of our planet's curvature. One of the most straightforward pieces of evidence is the way objects disappear over the horizon. As a ship sails away from the shore, we see its hull disappear first, followed gradually by the masts. This happens because the Earth's curvature obscures objects from view as they move further away. Section 6. The Earth's shape, evidence from space. With the advent of space exploration, we've been able to obtain irrefutable proof of the Earth's spherical shape. Satellites orbiting our planet provide stunning images that leave no doubt about its true form. From space, we can see the Earth in its entirety, a breathtaking blue and green sphere suspended against the backdrop of the cosmos. These images serve as a testament to the power of scientific inquiry and the ingenuity of humankind. Section 7. Flat Earth. Debunking the Myths. Despite overwhelming evidence to the contrary, some people still cling to the belief that the Earth is flat. They often cite various conspiracy theories and pseudoscientific arguments to support their claims. However, these arguments have been repeatedly debunked by scientists and researchers. The evidence for a spherical Earth is simply too strong to ignore. It's important to approach such claims with a healthy dose of skepticism and to rely on credible sources of information. Section 8. The importance of scientific inquiry. The idea of a flat Earth highlights the importance of scientific inquiry and critical thinking. By questioning our assumptions, testing our hypotheses, and relying on evidence-based reasoning, we can arrive at a more accurate understanding of the world around us. Science is not about blindly accepting what we're told, but about actively seeking out knowledge and challenging existing ideas. It's a process of continuous exploration and discovery. driven by curiosity and a thirst for understanding. Section 9. Conclusion: Embracing the Spherical Earth. In conclusion, the notion of a flat Earth is a fascinating thought experiment, but it simply doesn't hold up to scientific scrutiny. The evidence for a spherical Earth is overwhelming, from the laws of physics to the observations we make in our everyday lives. As we continue to explore our planet and the universe beyond, it's essential to approach our inquiries with an open mind, a healthy dose of skepticism, and a deep appreciation for the power of scientific inquiry.